Whenever we build something immense, there is a strict cost. You need massive amounts of energy, physical materials, and a deliberate architect pulling the strings. That is the basic logic of construction. When you look up at a night sky filled with trillions of stars and endless galaxies, it seems like a necessity that this scale requires an unimaginably powerful creator. An infinite cosmic structure surely demands an infinite power source. But modern physics and mathematics suggested different reality. The actual energy required to build this entire infinite galaxy-filled cosmos is exactly zero. Our universe operates as a mathematically net zero system. This means the absolute sum of all energy in the cosmos cancels itself out completely, removing the need for any external power source to kickstart the process. This mathematical reality is why cosmologists like Alan Guth refer to the universe as the ultimate free lunch. It is a system that appears to have spawned directly from absolute nothing. If everything around us mathematically amounts to a total of zero, we have to determine if a universe like this actually requires a creator, or if it is entirely capable of spontaneously creating itself. Think of the cosmos like an accounting ledger. On the positive side of the sheet, you have all physical matter. Every star, planet, and ray of radiation holds massive amounts of positive energy. On the negative side of that same ledger is gravity. Because gravity is an attractive force pulling massive objects together, it acts as a massive reservoir of negative potential energy. You would have to expend positive energy just to pull those masses apart. When you run the numbers for a system as large as our universe, the immense positive energy of all that physical matter cancels out the negative energy of the gravity holding it together. The grand total equals zero. Because the net sum is zero, the universe can grow and generate new matter without violating the laws of physics. Both sides simply increase at the same rate. Since no extra net energy is required to maintain this balance, the system does not require an external battery or a creator to exist. If the total energy requirement is zero, then we must explain the physical arrival of the universe from an empty void. In 1948, the Casimir-Serif experiment tested the properties of a perfectly sealed glass container pumped entirely free of matter, air, and light, a completely empty vacuum. The experiment revealed that space is never truly empty. Even in absolute nothingness, the vacuum boils with tiny virtual particles, spontaneously popping into existence, colliding, and vanishing instantly. This process is known as quantum fluctuation. At this microscopic quantum level, time does not operate like a ticking clock. These fluctuations happen randomly, entirely outside the boundaries of a defined before or after. If you apply that proven quantum behavior to a cosmic scale, our entire universe can be viewed as a single, massive, spontaneous quantum fluctuation. From a physics standpoint, nothing is not a dead, empty void. It is a highly active state mathematically capable of spawning a baby universe. A standard quantum fluctuation produces events on a subatomic scale. To go from a microscopic spark to an infinite cosmos, another force must be at work. This is where cosmic inflation comes in. Immediately after that initial microscopic spark, a specific energy field called an inflaton caused that dense region of space to violently stretch outward. This process was not a gradual growth. In a fraction of a second after the Big Bang, space itself expanded at an incalculable rate, infinitely faster than the speed of light. We see the proof of this expansion in the cosmic microwave background radiation. These tiny temperature variations mapped across the sky are the exact thermal patterns expected if microscopic quantum ripples were suddenly stretched to cosmic scales. Inflation is the mechanism that took a microscopic, zero-energy quantum spark and blew it up to create the massive canvas of our reality. But creating that canvas almost led to immediate self-destruction. Quantum fluctuations always create particles in equal pairs, one part matter and one exact copy made of antimatter. When they touch, they annihilate each other. If the universe created equal parts matter and antimatter, everything should have collided and wiped the cosmos blank instantly. Yet planets, stars, and people exist today. The explanation for why anything survived comes from a set of rules developed in 1967, known as the Sakharov conditions. These conditions outline a slight asymmetry. For every billion pairs of antimatter, the initial expansion produced exactly one extra particle of regular matter. The rest annihilated into photons. Every star, galaxy, and human is built exclusively from that tiny surviving remainder. Human existence is the result of a 1 in a billion mathematical glitch during the universe's most violent phase of self-destruction. We can now trace the mechanical process, a spontaneous quantum spark, kept mathematically balanced by the negative energy of gravity, violently stretched by inflation, and left with physical building blocks thanks to a tiny asymmetry. This leads top physicists to a profound conclusion. The universe is a completely self-contained system. The laws of physics are robust enough that the cosmos does not require an external creator to push the start button. While we can point to the precise physical rules the universe followed to construct itself, the entire model rests on a single silent assumption. Every step of this model relies on the fact that for a quantum fluctuation to occur, the laws of physics, mathematical symmetry, and quantum fields had to already exist within the nothingness. If the universe didn't need a creator to spark the physical material into existence, who wrote the unbreakable rules of mathematics?